Okay, well, I'm glad I have an audience of developers. You guys all have lots of stamina. Working for 12 hours is not a problem. Staying focused, everyone's really quite alive. I was thinking I would have to do something really drastic to keep everyone awake, and I might try a little bit of it anyway. My plan was, well, okay, so this talk was originally announced as being about AppleScript, and as I thought about it more, I realized that that's really not, that's too narrow a topic. So I want to talk a little bit about, well, really, another way of looking at this talk is it's what I've been up to lately. So either it will look like just an advertisement for all the different things I've done lately, or it will really, but that's not really what's going on. What's going on is that as I think about these things, I'm trying to fit them into some kind of a coherent picture. And one way of looking at that is that they're all different ways of solving a particular problem. And so my drastic approach to keeping everybody awake was to say, let me just throw out my slides, and all we'll do is sit here and have a design session and try and solve this problem together. My friend Martin Ganholm, who I co-founder of one of my last startups, is here, and this is the most fun we ever had, right? You put up a problem, you've got a bunch of smart people in the room, and you say, all right, what do you do about this? So the problem is, yeah, where's the pizza? Exactly, that comes later, all right? And maybe so the idea is, okay, so we all have these, generic situation where we've got some client that's calling some application, and normally you'd think, okay, this application is written in some object-oriented style, so it's got lots of functionality in it and APIs and things, and this client, well, it could be anything, but I'm gonna also think about it like a scripting language, let's say. You want to just, we've seen lots of examples of this today. And the only thing that makes this interesting is I want to pose this other constraint, which is that the communication is really slow. And so I'm gonna refine that a little bit because that's not really very precise. What about the communication is slow? And one thing I've realized is, well, okay, so we have bandwidth and we have latency. And so one of the things that's going on is that the relative increase in essentially the bandwidth of communication is going up much faster than our improvements in latency. You want to have the latency be smaller. Latency is the time it takes to get a response given a request. So this is a chart from a paper by Dave Patterson showing that essentially this is a log scale and showing that the bandwidth of a network and microprocessors and disk and everything is going way up, but latency isn't improving that fast. And the reason is the speed of light, right? You have distances, and you just can't throw more kind of computers at the problem and get latency to go down. So what's happening is we're getting essentially a latency effect that even as we get more and more bandwidth, things get faster and faster, we still have a certain amount of latency, and it's hard to avoid that. So what I really want to talk about is, what if we've got this client application scenario and the latency is high? And I'm talking about latency of, a tenth of a second, right? So you do 10 calls between here and there, and you got a second. What about a latency of a second or a minute or an hour, right? Where you're doing a business transaction and they're going to take a while to get around to it. It's queued up and it comes back. And so the challenge really, and what I want to talk about today is, how do you program? What's the programming language model for dealing with situations where you have a lot of latency? So, like I say, anybody want to tell me solutions? How do we do that? What do we do here?
The first thing you do is reduce the amount of communication.
You reduce the amount of communication. Yes, and so that's the number of communications.
Yeah,
right.
The number and the quantity.
And the quantity. Well, so bandwidth we don't care about. So if they're big, then that's fine.
Reduce the number.
So in Sriram?
You haven't actually defined the problem, Will. You haven't told me what you're willing to give up. Are you willing to give up a little bit of correctness? Are you what sort of false you want to tolerate?
So, so this is it, when I do interviews, this is always my favorite thing, right? Ask a really ambiguous question, and the bad developers will answer it right away. And then you don't hire them. And the good developers say, well, you haven't told me, what about this? And they ask 10 questions.
Yes.
All right. So yeah, we had some. Okay, so what else did somebody say? They said cache, right? And I should have put a slide in on caching. What were some of the other suggestions? Just shout them out. Whatever. Parallelism. Okay. Excuse me? Move things, move the application to the client. Yeah, so move something. Prefetch, which is, yeah, pipeline. So, anybody else got another one? Those are all good.
Load some picture.
Excuse me?
Load some movie or picture so client can watch.
Oh, entertain them.
Make sure there's a copy of mine.
I always wondered what those ads were for on web pages. You know, the ads always come up first. So, okay, well, this is great. Asynchrony. Yeah, so you can, maybe futures kind of fits into that. Okay, so one more?
Yeah. Guessing.
Guessing? Okay, so that's speculation, right? They call it speculative. Okay, so maybe we could dig into these more. So my, okay, well, let's.
Progressive delivery.
Progressive? Okay, so do it in sort of, I guess, streaming or something.
Course first, finer details.
Okay, yeah, yeah. Okay, so this is much more, this is a typical thing, right? I have a few ideas. These are much more than I had thought of. I hadn't thought about it that hard. I just thought I'd ask you guys. But the interesting question that I have is, how do these things impact the programming language?
No.
No?
Well, yeah.
Do they impact your programming design? They certainly impact your designs. So another way of looking at it is this. If you have an idea about, let's say what you'd like to do is design it as if it were local, right? You know, and not worry about all this issue, and then somehow have it be. You'd like to not have to worry about the latency, but maybe. Or at least make it manageable. I'm not saying you can eliminate it completely, but the question is, how do you manage that and still be able to express your design? So if your design is to get some actual work done here, but you spend all your time doing plumbing to make all this, you know, sort of fancy stuff work, I feel like that you know, it's a question of where you're spending your time. So if you'd like your infrastructure to handle some of this and support these kind of features, and so the language is one element of the infrastructure. If you could do it all with a library, you know, could you implement, you know, parallelism just as an assembly with a couple of calls in it? I don't think so necessarily. I mean, it's a more pervasive kind of thing. So that's the thing I'm worried about. Other comments? Yeah.
Yeah, you're having me think that you would love to be able to write it as a self-contained thing, and yet you'd like to have some way to attend to the fact that not all operations are instantaneous.
Yeah. So that's kind of the fantasy that we've had for a long time, and in particular, one of the, I think, at least my take on it was one of the kind of rallying cries of objects and Corba and DCOM and stuff like that is that, you know, you just write it and then naturally you just distribute it and it just works, right? And so I don't know. I did put a slide in on that one. So the pure object-oriented design, right? You just design your server as application objects, and you just make your client makes method calls, and you have automatic proxies, and marshalling, and all these good things that everybody talks about. And it's elegant, it's familiar, it's lots of people working on it and stuff. And the problem is that it just is a complete disaster, right?
No, it's the same. No, it's the same problem that you had with the Iron Python claims. That people say that people are confusing the platform with the particular implementation. So you just have to learn a lot of different things to get that working.
Well, okay.
I mean, that doesn't work.
So let me address that. Okay. Does someone else want to address it?
I want to disagree.
You want to disagree?
Yeah, I want to suggest the problem is you can't hide things.
Yeah, so I have a quote on there. Abstraction is great unless the properties being abstracted are the essence of the problem that you're trying to solve. I heard that last week at eCoop, Steve Cook, who's also at Microsoft. And so this is a really key point, because whenever I get into a discussion about this with a Corba person or a decon, whoever, they always say, oh, but you can work around it. You can solve this problem. And you can use value objects and other design patterns and all this other stuff. And I guess what I make a distinction between what's natural to do and what's possible. And so yes, it's possible to do it, but you end up kind of backing off of the kind of claims of what the services and what all the good things that Corba does for you, like these automatic proxies. In order to get a good solution, you better not use them very much. Okay, so why are they there? And that's the sort of fantasy of solving this problem. I hope I'm keeping people awake here. That was my goal. Are we doing okay? Okay. So, maybe I'll go through this one really quickly. I wrote a paper recently where I just sort of hypothesized, what if Corba had been used to design HTTP? And I made some nice interfaces. And the reason why I did this is that I kept seeing these papers that were comparing web services and Corba and showing that web services are 2 orders of magnitude slower than Corba or DCOM or whatever, RMI. And they always did it by having a one-line procedure, that you call it and it adds 2 integers and returns. And that you could do that much faster with Corba than you could with a web service. And so I said, well, what if we did, so what they're doing is they're taking an RMI kind of Corba RPC optimal kind of scenario and using that as the basis of the comparison, so it wasn't fair. Now I'd said, well, maybe we should pick one that web services are good at. And so if you have a lot of very chatty interface, which is a natural outcome of sort of a natural object-oriented design, then the Corba structure is really slow. And so you can actually get the web service to be much faster. So yeah, I kind of, you get this chatty calling methods, and every time you call a method, you get an automatic proxy, and every time you do that, it's a round trip. And it's basically just, the web would have failed if we had done this. Just for that reason alone. Of course, then there's the whole issue of binary interoperability and all that other stuff. I heard a great talk by Don Box a couple of years ago where he basically says you can't take something that works locally and make it remote. This is the same issue. You can't hide latency. But if you have something that works remote, maybe using it locally is okay, right? So the issue is, how do you come up with a framework and a foundation that makes it natural to create the kind of designs that are effective. And so I'll work on that. But I got to say that you just do it in the pure standard object-oriented way, it's not going to work very well. And so that I would argue that the framework isn't supporting us very well. Okay, so yeah, the issue is that these sort of simple, elegant solutions don't necessarily scale up. And what I'm looking for is the other question, is find solutions that do scale up and then try and make them as elegant as possible. And that's where I'm headed. So these. All right, so I'm gonna be able to touch on a couple of these, but I haven't. These are all these might be good more research areas here. So what I wanted to do is talk about a couple of ones. And so what I'm doing is I pose the problem, and I'm going to talk about 3 or 4 different ways of solving this, the ones that I've worked on, and there are other ones. And so this is kind of leading up to AppleScript. So one way of doing it is if you can get the client to send the work up to the server in kind of a batch. Like there's all this stuff I need to get done, rather than doing it as a communication. If I could send a description of all the work I need to get done, then the application can do it and get back to you. And then related to that is if you could just get all the data down in one go, that's kind of the prefetch idea. So these are these two, moving it and well, somebody said move it to the client. I'm talking about moving it to the server, but it's similar. And then prefetching, or also that typically there's some work that does need to be done in the client, and can you partition the work is really what it comes down to. And does your framework support that? So One thing about it is to look at it is that if you start moving the code around, that might cause some problems if you have multiple applications that are being talked to. How do you move it to both of them at the same time? Just a kind of a caveat there. And similarly, if you're going to bring some data down, there's this big question of how does the client say what data to get down, and how does it know what it needs? Right? That's kind of a modularity issue. The data that the client needs depends upon what it's doing. And what it's doing depends upon all the different methods that it's calling. And if somebody in maintenance adds a new method call or a new need, and a new piece of functionality, that needs to get filtered back up somehow into this communication. So the point is that the data that you need is a global property of the whole behavior of a transaction, say. And if you have to state that up front, it can cause a maintenance problem. So I'm just trying to spec out the problem a little bit. Okay, so now I have a particular solution, and this is kind of a historical one. This is what I was doing in 1991. After doing some research, I wanted to do more commercial software development. This was my first company product. I had developed, products that people had used kind of in a more open source style before that. And so the interesting thing about the Mac OS, like the very first thing that you run into is that it could only do 60 process switches a second. And so in effect, the latency of a call, a method call from one application to another is quite high. And if you think about the number of method calls you typically do in an object-oriented programming language, 60 calls taken a second isn't really going to, it's not really happening. So a little bit of this analysis happened before I got there, and they had developed a notion of Apple events and a lot of infrastructure around dealing with this problem. And basically what it amounted to was being able to describe operations on a remote application's data and have that be defined in terms of some kind of a terminology. So these words like color and character and document font, those are properties of the remote application. They're just like, this is a hypertexty, it's an English-like syntax that was inherited from HyperTalk, which is the scripting language from HyperCard. And this is actually funny because Martin also worked on HyperCard a lot, coming back full circle again. But we did a sort of a C-like dialect too. AppleScript had a notion of multiple different syntaxes that could be loaded dynamically in. But I stick to this one because this is the only one that's supported today. But so you could create expressions out of this that were like traversing fields and doing tests. And what would happen is that these things would in AppleScript you could create what were called object specifiers, which are expressions involving remote applications terminology. And so the way that things worked is that these object specifiers would get sent remotely to the remote application for interpretation. And the whole object specifier and the verb associated with it would get sent remotely. So all the work would happen on the other machine. It wouldn't download the data. It would upload a description of the operation to be performed. So we had these properties and elements, and you could have verbs. So there were generic verbs, but also specific verbs. And these when you wrote a script like this, it got to execute that, it would actually build an Apple event that had a description of the operation that needed to be performed on the remote machine, and it would send it off. And so that would all be essentially one round trip to do that operation. And other kind of interesting things about it is that the way these things were encoded was actually into a generic tree-structured, tagged, semi-structured data format called Apple Event Descriptors, which obviously are, XML was invented millions of times, I'm sure, over and over again before it finally got a text representation. That's one thing that these didn't have, was a text representation. So the other thing about Apple, so I'm not going to say too much about AppleScript. Like I said, I'm talking about this other problem. But it did have some interesting other aspects that I'm not going to be able to talk about today. In particular, you could have an application that could be driven by, so the red arrows is AppleScript calling applications. That's what we just saw, right? And it could call multiple applications, and that's nice to be able to automate them all and do it in this high latency style. And but the other thing that made it interesting is that the applications could also call AppleScript. So it had a notion of script, a generic script API, script management API, where you could load scripts and compile them and execute them and ask them to process events that would allow an application to be able to have AppleScript as its internal scripting language. And this is all very familiar to people now if anybody's used the Windows scripting host or VB integration, things like that. But this was even before any of that stuff happened. But it did allow AppleScript to act as a glue between applications. So it was a good idea. But I think this other idea, like I said, about the latency is quite interesting. The other thing I wanted to point out is that these object specifiers, these paths or descriptions of remote objects, were first-class values in the language, and so you could store them in variables and extend them. And basically, if you start looking at this, it should look a lot like link, D-link, because it really is very similar. It's hunks of expressions that are stored in variables, and then when you use them, they're evaluated lazily by being sent like a query to the remote application. So I'm not going to claim that there's any connection in terms of D-link having been developed, but it's interesting to note the similarity. And you could talk to applications, multiple applications, and they basically had a policy where it would go and get the data from one and then send it off to the other one. So in terms of AppleScript, the interesting thing about it is that it has this kind of faux object-oriented style. It looks like object-oriented programming to some degree. You're accessing properties of objects and navigating around, but it didn't get implemented. It wasn't executed in the normal way. So that's all I want to say about that. I guess I should mention that there were some serious limitations for AppleScript. For example, every one of these commands, a single line, was always sent as an event. So if you had two of them in a row, it would need to do 2 round trips. It wouldn't batch them into a combined unit. So there definitely were things that could have been done better. And then there's also this interesting issue about that I really want to focus on next, which is how it did the second half of my diagram, right? I had that thing that says the application can send the work and it can also get the data down. And so the question is, how do we get data from an application? So I'm going to switch over. I spent a lot of time working on databases and programming language integration. And so I'm going to do some of the same thing. And what I want to do now is talk about some enhancements, perhaps, of D-Link. And the way I'll get there is just talking about the same kind of thing, a query. And if you've got a query and you want to do a search, if you were just a programming language person and you didn't think about it as being in the database at all, you might just write a for loop and a test with an if in it, and then you do some work. And so that seems very natural. And the problem is that it doesn't do joins, it doesn't do queries and all that stuff. And maybe it uses some kind of if you're familiar with Hibernate or something like that, it might use orthogonal persistence to load things. This isn't just a latency issue because there's actually compiler optimizations that can be performed on this if you use an index and inverting the loop and all that stuff. So it's really a broader issue than just latency. But the key thing is this is using a linear search, and the database person's just going to tell you that's crazy. We can compile that much better and choose a plan based not on just on the structure of the query of the program, but also on the statistical properties of the data, right? It's it's not just the code, it's actually the data that depends. And you can get orders of magnitude improvements in performance. So there's clearly a huge benefit in integrating the sort of database optimization with programming language compiler optimizations. And actually, database optimizations are usually much more, in terms of order of magnitude improvements, they're more effective than the compiler optimizations. So that, if you've all seen this stuff, this just happens to be JDO. It's just like, ADO and ODBC and all these things that you put your strings into you put your queries into strings and you execute them remotely. And there's just tons of problems from this from a programming language point of view, embedding your code inside of strings. And D-Link solves that very nicely, large parts of it. And so, we saw some code like this. This is that same code, the 3-4 lines that I put up at the front, written out as a D-Link query. So I actually have some issues with this in terms of its, getting rid of the sort of object-oriented style of accessing properties and having to switch over into a more join-based model. And so maybe joins are natural in some cases, but in a lot of cases they aren't. And so that's not necessarily great. And the other thing that I really want to focus on is this issue of the anonymous result type. And what I want to analyze about this is, why does this thing exist here at all? The reason that we need these two values is that those are the two values that get printed out. And so this is the question that I was saying, is that if you're going to say what data is needed, the data that's needed is already known because it's in the program, in the print statement, but we're redundantly specifying it in the query. And so we're actually setting up, again, a kind of a maintenance issue that I mentioned. By the way, I did a paper last year that had an alternative proposal for this, very similar in some ways, but it uses, actually, it originally was done in Java, and it ends up being very similar, where you essentially just use a normal class with a filter method, and that it's like a predicate. You could use delegates. This actually was implemented by DB4.0 in Java and C#. It's called native queries. So there's other similar approaches, but the key thing is with this one is that it relies on an object relational mapper that's able to load objects on demand. So every one of these managers is going to get loaded on demand when it's needed. And that's not good. So I guess my summary on this database programming language stuff and D-Link is that a typical use case of a typical transaction does two things. It finds a bunch of objects of interest, and then it does something with them. And the finding part, we've got a pretty good handle on that. We can specify the query as an expression and ship that off to the database. But the second part of doing something with the results is a little more problematic, because we have to say what we're going to do. We have to say that we're going to use the data, and we also have to say which data we're going to use. And we have to do that redundantly. We have to do that twice. So a similar kind of thing here is that I can illustrate that a little better in Hibernate. So in Hibernate, you can just do a query and have your condition, and then use the objects directly. And related objects will get loaded on demand as needed. But what you really want to do is to prefetch them. So that's our second issue over here. You want to prefetch the ones that are going to be used. So one idea that I had, and we actually built this into Hibernate, and I'm thinking it could be interesting for D-Link, is to, let me just mention the way Hibernate works. You can actually tell Hibernate to prefetch. But if you do that, you're getting this dependency again, that you need to put the prefetch up here in the query because you need the data down here. If you change down here, you have to make the corresponding change there. The connection between them is very subtle. It's essentially not, it's only an optimization, so you can't write a test suite very easily that checks it, right? Because the program will still run even if the prefetch is wrong. And if this were calling some other, function, a method that used the manager and maybe some other related information, the distance between the query and the place where the query result is used can get greater and greater. They don't have to be in the same place at all. So you have a real modularity issue. So what I did with a student was figure out a way to do automatic prefetch in this kind of model. And it's pretty interesting. You can essentially just do dynamic profiling. Run the query the first time. Watch what results it uses. It starts with the person, it goes and gets the manager. Starts with the person, goes and gets the manager. Keep track of that. And then next time the query runs, just go ahead and prefetch the managers, because the last time they were needed. And so you can just collect statistics dynamically And then you don't need to have any of this manual prefetch stuff. And so if you look at it, here's a benchmark torpedo that's actually based on counting number of queries executed. And initially, yellow is the one without any optimization, and the green is the manually optimized, and the pink is the auto fetch. And so the first run, it does really badly. And then the second run, it executes the same number of queries as the manually optimized one because it's able to figure out what things need to be prefetched. If you run that on 007, you actually go from 3,000 queries in the T1 traversal down to 38. So it just figures out what needs to be prefetched and wipes that out.
Exactly how it figures out.
It watches so it instruments the objects that get returned from a query. It instruments them.
It matches exactly the query stream.
Yes. So it does that based on, it has to check that the next query being executed is similar to the previous query. And it actually uses an abstraction of the call stack and the query string. And so even if there's a helper function that's calling the query, even if there's a single query method that gets called by two different case situations, one that uses the results in one way and one that uses the results in a different way, it'll keep track of the prefetch for those two different cases. Caller plus the string, yeah. Now you could use AI to maybe infer the correlations better, but that's what we do.
Do you use triggers or something to make sure that you're only doing prefetching, so you're not making any caching assumptions?
No caching assumptions, yes.
Caching.
Yeah. So it doesn't optimize the initial query. There's some other work called Prefetch Guide, which came out of some work by Phil Bernstein that it does this similar kind of optimization within a single query. It's kind of interesting. And so it's able to work on a single query, but you could combine the two. So AutoFetch, it's able to get because it can predict the prefetch, it can actually modify the query the next time it's run and execute just one query. Okay, so I think I might skip this part. I had a little notes on web services. We already talked about it. There's some ways to use essentially sort of an asynchronous or batched future model to hide these proxies. Basically what you do is I should probably skip it. Anyway, the point is that there are lots of different ways for dealing with this problem, and it's a fundamental problem. And so there's another one. I think, how am I doing on time? 4 minutes? Okay. Well, let me just hit you with this real quick. This is work in progress. And so this is my latest attempt at the problem. And basically what it comes down to is, I guess I don't fully believe the sort of relational queries and joins and stuff are the best approach. I actually like this way of writing it, as a loop with an if statement and do something. Oh, he was telling me I had the wrong time. I was a little worried about that. I suddenly have 20 minutes. All right. Well, these sections are kind of modular, so why don't we do this one, and if we like, we'll go back and do the web services one, since we jumped over that one. So I guess what I'd like to do is just write my object-oriented program the way I like to write it, but I'd like to get full query optimization, full prefetch, have it all just work and do the right thing and generate, great queries and be able to just write it straight. So I don't know if it's possible really, but I've taken a stab at it. Yeah.
At the moment, what's the difference between this code and what we saw with D-Link? For me, D-Link is synthetic sugar compared to this. Are they complementary? Couldn't we have, because D-Link doesn't say anything about optimizations of the query at the moment and all that.
D-Link is written, so what you're doing is you're writing in a sub-language that makes it easier for D-Link to do the optimizations, and that's good. Having a sort of more restrictive sub-language that kind of assumes that optimization is going to occur, I'm sort of saying, well, let's just go back out into the wild of arbitrary, imperative programs and see if we can optimize them. The other difference is that D-Link had that issue of sort of the communication between the query result set having to contain just the data which is needed for the rest of the program to use. And so I'm trying to avoid the need to specify explicitly what the result set is. Okay. It's almost like inferring the result set. Now, maybe you could extend D-Link to infer the result set, and that might be good. So I'm not going to take an absolutist approach on this. I think D-Link's great. I still think the issue of the result sets is probably the one thing that needs to be worked on that I know about. No, I shouldn't say one thing. It is a thing that needs to be worked on. But I'm just going to say, let's see what we can do with this more sort of open-ended problem. So I don't know how well this is going to work, but basically I've been struggling with this, and I went and finally figured out that what's needed is a notion of abstract interpretation. And so abstract interpretation is a very general, powerful theoretical tool for taking the semantics of a programming language and replacing the specific concrete values with abstract values. And an example would be, let's say you had a computation over integers. You could, instead of computing over integers, if you replace the integer set as your type with, say, well, one abstraction would be parity. All we're going to keep track is whether it's even and odd. Okay. Now you might still be able to compute abstractly when you add two numbers. If you know that they're both even, then the result is still going to be even. Right? If it's even and odd, you can kind of get track of parity there. If you don't know, and then you also need to have a don't know value. It's like it's either even or it's odd or you don't know. And so what happens is as you abstractly execute the program, you can compute an abstract value that represents an abstraction, a property of the real value that will be computed at the end. And it turns out that, for example, type checking is a form of abstract interpretation. Instead of, you run the program, but instead of running it on the actual objects, you run it on types. And you know that if you call this method on type A, it's been declared to give you a type B. That gives you the abstract value of the result. It's now a B. And so and the other thing you do is you don't actually run loops, iteratively. You just run them once, kind of abstractly, and do well, you need to kind of simulate the multiple executions of that loop until it reaches a steady state of all the constraints that are being collected. So the point is that if we can replace the database values with paths that got you to the database value, then that's an abstraction that represents what it represents the set of database values that you might get if you traverse that path. And so I'm going to talk about basic paths and adding conditions to paths, and then trying to create queries and stuff like that. So let me just illustrate it. So here's our code fragment, and it's got some paths in it. We take employee and we look at this employees and we get them into the variable emp, and then we get the salary and the name and the manager's name. And I can summarize all the different paths as a tree. Start from the root, we get the employees, and then this iota here represents the iteration variable. It's an abstract value that represents all of the different employees. So we're going to ignore the fact that there are multiple employees and just summarize them as a single abstract value. That essentially represents an arbitrary employee. And then from one of those, we're going to get the salary, the name, and the manager's name. So those are all the paths you get in running this program abstractly. Now, the other thing we can do is we can analyze the conditions under which the different paths are used. The paths are not just always used all the time. There might be certain conditions that govern when they're used. And in the abstract interpretation, we can keep track of that by annotating the fact that the salary gets used all the time, but the name and the manager name are only used if some condition is true, namely this red condition here. And I can summarize that as an abstract value representing its condition. And then the other thing I did was I flagged this salary in a special way, and this is a little bit tricky, but it has to do with the fact that the context in which the salary path is used is an if statement. And if statements only affect the control flow of the program. They don't affect the data, the actual data result. Okay, they don't get assigned into into any variable. And so we need to keep track of how the variables are used as well. And so this is the result of abstractly interpreting that program relative to replacing the database values with paths.
So theoretically, William, a developer could create a path that could result in no data. Like if this were the optimizer could optimize that away, it wouldn't actually execute the SQL or the query
Well, no, you see, the issue is that we don't actually know anything about the real data. So if it traverses a path, it's going to have to ask the database whether or not there are any objects.
It still has to add.
Yeah, it still has to ask to get the real data later. But we can figure out, eventually, for example, you might be able to figure out that certain fields are only used under certain conditions. So they only need to be loaded if that condition is true. And all right, so then we basically proceed with this analysis. And
Perhaps we just should sort.
excuse me?
We can sort the employees regarding their.
Yeah, so I left out sorting. Right, but sorting would be another expression, like the if, that would need to get recorded as being used, a path that's used. So that's not a problem necessarily, but
We're talking about analysis at compile kind of time.
this is total static compile time analysis. Absolutely, sorry, I should have mentioned that. The previous thing with autofetch was a dynamic analysis, and this is an analog of static analysis. Static analysis is the kind of stuff, right, you do in compilers, so this is a variation on that. And there actually are some interesting cases that I didn't mention in the talk, but if you do, certain things will get you into big trouble. Like if you had the for loop, and you said E equals E dot manager in there, where E was assigned to be a person. So what's going to happen is every time the for loop goes around, you're going to go up the manager tree one more level. And so what you've abstractly, if you looked at the path here, this is a E equals E dot manager. The abstract path is actually E dot manager dot manager dot manager dot manager dot manager. It's an infinite. The only abstraction you can get for that is the infinite path, because that loop, you don't know how long a loop is. That's one of the things about abstract interpretation. Because you don't know exactly how long the loop is, you have to assume that it's unbounded. And if it's unbounded, then you get an unbounded length path. And so in this case, if you did this, the analysis would fail, or it would tell you this query can't be optimized, which is fine. The fact of the matter is that people don't write that. Now, I'm not saying you'd never write anything like that, but that particular case, there's no relationship between. So other things are allowed. If you said A equals B dot manager, that's fine, because we're taking one value, taking the manager 2 levels up, and assigning it into a different variable. That's fine. You're just saying you're going to get the grand manager of that person. So I'm not saying that any use of any repeated use of the manager field will cause this problem. Only certain ones. Okay. I'm skipping out a lot of details here, but I'm interested in feedback on this because I just have a paper, it's under submission, and I'm trying to get some exposure for the idea. So the other trick that we have to do is take those conditions that are down here, because the conditions are actually at the level of individual fields. But not loading a field isn't very useful in a database application. What we need to do is avoid loading entire employees. We don't want to get the entire employee set. We want to get just the ones we need. So what we need to do is promote these conditions up here. And we can do that if every single field in an object is only used under that condition, except fields that are only used for control flow. Because those aren't going to affect the final data. They're only going to affect the control flow. So we can promote the condition up. And then from that, actually, there's a pretty straightforward transformation to take a bunch of paths and turn them into a query that loads that set of paths, the data that's referred to by that path. And the conditions become aware. This is written in OQL, which is, again, another kind of query language that happens to be convenient because it allows, it actually is very similar to the D-link idea of being able to have a select. If I just took the select and put it at the bottom, I think it would be D-link, more or less. Instead of struct, replace it with new. I think that's the difference. But so these ideas are all floating around. They're very similar. Anyway, so the idea is that given this program, you then can take that query and generate it as an actual query. And what you're doing is the point of what a query does is it takes a database and it produces, one way of looking at it at least, is that given a database, it produces a subset of that database, which is the data you need. You don't need it all, you just need a subset. And if you can get exactly the subset you need, that's good. That subset is kind of like a mini version of the real big database. So after running this query, we get a result which is analogous to the original database, but it has less stuff in it. Only the stuff that's needed. Remember, I've got this idea of what's needed depends on what the program does. And the other tricky thing about this is that we know that of the employees we're getting, all of them satisfy this condition. Their salary is greater than $65,000. So we don't actually need to test that anymore in the program. So we can do one more step where we essentially erase stuff from the program that's known to be true about the data. If it's testing something that we already know to be true, then we can get rid of it. And after doing that, we don't need to load the salary anymore. So anything that was in the condition would go away. And if you do that, you basically get the handwritten query that you would have written if you were doing this in a more query-oriented programming language. So anyway, that's my current work, and I have a lot of there's a lot of issues with this. We've actually proven parts of this stuff correct, but there are parts that aren't proven yet, and we've also haven't covered all the different things. We haven't done aggregation. We haven't done updates. All those might be possible, and we haven't. I haven't applied it to big programs. I mean, I was an enterprise software developer for many years, and so I have some experience with what kind of queries are typical, and I believe this is doable, but I haven't demonstrated that yet.
Is there a naive translation from the for each loop into an extremely inefficient query and then allow the SQL query optimizer, or whatever, any query optimizer, to do exactly those same transformations?
Well, I think the problem is not getting the query to SQL does what it does really well. The problem is figuring out what the naive query is. So in a sense, we're not trying to make the best query ever. I mean, in a way, maybe we're taking that approach. We're just trying to say, what is the query that's implied by this program? Extract that out and give it to the database.
So I was wondering if there was an easy naive translation that didn't involve the abstract interpretation for each loop. It says, select all employees, and then has filter clauses.
Maybe so. I don't know.
So is this, does it work as preprocessor?
This would be the kind of thing you might build into a compiler or do as a preprocessor. Yeah, so we're implementing the analysis now, and we're going to run it on some programs and find out. But yeah.
What are the circumstances where, like, for control flow, that you don't know ahead of time what those conditions
Yeah,
are?
the way that abstract interpretation works. Oh, sorry. The question was, what about the control flow? You don't know which branch it's going to take. Yeah.
So that's it, because maybe that value that you're testing specifies
Yeah.
as runtime. So now you can't actually create ahead of time that query.
Well, okay. So, I mean, it doesn't matter whether this is a constant or not. It does not matter, because you can do the same analysis that if this is a variable, the issue is a dependency analysis, data flow analysis. If this is a variable, if that variable is assigned a value up above the point where the query needs to be executed, then we can capture its value then and create it as a query parameter. Okay, so that's fine. But the issue is that if you had a variable x in here and you assign to it in the loop, then you'd be dead. Right? You can't in the middle of a loop change the search criteria for the subsequent elements of a query. And so if you wrote a program like that, it wouldn't be able to be extracted as a query, and we would detect that.
Okay, but from what I understand also, you're using the search criteria to analyze also in what circumstances do I need to
Yes,
check
but
values of the fields.
we're doing it abstractly. So all we're looking at is that this is used under some expression. We don't need to know the actual, we don't actually evaluate that expression. We just use it symbolically. And so if the symbolic expression has variables in it, it's fine as long as those variables don't change between the point when the loop starts and when the condition is executed. But that's a really good question. Yeah. Other questions, comments?
So potentially, can it show any strategic advantages over delete?
Does this show? This is a research idea, so I wouldn't get down to making any kind of evaluation of the quality of this versus D-Link at this point. I mean, it's really designed to it's an alternative to solving the same problem, but I can't say whether this is going to work yet. It's an interesting idea, so I'm pursuing it. I think that I'm motivated by that key. So I would think that in the near term, it would be more important to work on the result kind of auto-fetch stuff, to infer what the results are needed from a query. And that would be an interim approach.
Do you have a web page or a mailing list where people can follow that development?
Yeah, so if you search for William Cook, I think on Google, I think I actually have managed to get myself on the first page. Let's see. Oh, I'm not online. Sorry.
Throw in Austin.
Yeah, UT, William Cook, Austin. Yeah.
You're the second link on Google.
Okay.
Work harder.
There are millions of William Cooks, so I'm doing pretty well. Okay, so let me just finish here. So anyway, a bunch of thoughts. These are all just different solutions to this issue of latency. And so I had AppleScript, which has got this sort of faux objects in the sense of English, right? The subject, the name of the, document one, that's an English object. And it sends the work to the server. This distributed objects and web services thing, I didn't get to talk about it too much, but I have another paper that talks about ways to essentially batch up the operations and deal with that. I think I'm out of time. And then I talked about autofetch, which is this dynamic profiling to figure out what results should be returned from a query based on the way that those results are used. And that's a dynamic approach. And then finally, this query extraction, which is a static analysis for doing something similar. And the dynamic analysis and the static analysis might actually be complementary as well. And so I started this off with sort of this hurricane. That's the way I think of it, is this sort of swirling mass of interconnected ideas. And so that's what I was trying to sort out for you. I'm not sure whether that completely succeeded. But anyway, and I actually would love to talk about more of these because there may be even more issues. I didn't have a slide about caching. That's a really interesting interaction. I tend to be in sort of the Microsoft style has tended to be not much caching. You just rely on really good queries and don't cache the entire world, because if you're having load balanced multiple servers and stuff like that, cache coherence becomes a problem. It's easier to just let the database deal with that. But I know a lot of people are really fervent supporters of extreme caching. So I did this one. What did I do? I did reducing number of communications, moving stuff, prefetch. I don't know about, and maybe a little bit of async. I don't know about pipelining, parallelism. I haven't thought about that. So, all right, I'm done. Thank you.